It is testing your understanding of the arithmetic sequence. Okay? The question says, the 15th and 3rd terms of an arithmetic sequence. Okay, you should know what is an arithmetic sequence, what is the general term of an arithmetic sequence. Okay, so this is the keyword in the question. Okay, those two are very important. Okay, so the 15th and 3rd terms of an arithmetic sequence are 128 respectively. Determine the 100th term. Okay, so you need to determine the value of a term which takes the position 100. So you need to determine the value of T100. Okay, now this is an arithmetic sequence. We don't have the first term in the question. We don't have a common difference in the question. Since you don't have those two, it means you have to create two equations that will solve simultaneously. That's the reason why you did simultaneous equations back in grade 10. That's one of the reasons. So that you can apply that concept now. So first thing here, I'm going to write T15 is equal to 100. Okay? But remember, what's the general term of an arithmetic is Tn equal to A plus n minus 1 times D. Okay? So here is T15, which means where there is n here, I'll put 15. Where there is n there, I'm going to put 15. Where there is Tn, I'll put what? 100. It's not difficult. Okay? So, where there is Tn there, I'm going to put 100. Where there is A, I'll put A plus. Where there is n, since we have the 15th term, okay, which is equal to 100, I'll put 15 there minus 1. Now, I don't know the common difference because I need to determine it later. So, I'll multiply that by t. I'm using the general term. That's taught in grade 4. If you want to do it based on your... No, for this question, you have no other way out. You have to use this general term. Unless if you decide to use the one that you taught in grade 10 or 11, that's fine. Okay? But I prefer that you use this one. Okay? But if you use the grade 10 and 11 one, it's still fine to get to the same result. Alright? Any question? Any question? Okay, from here now, you simplify and create a what? A linear equation. So that would be 100 is equal to A. This is 15 minus 1, which is 14. 14 times D, that will give you plus 14D. So you can call that one your equation 1. Okay? That will be your equation 1. Then equation 2, we are told that T3, the third term, is equal to 28. Again, I'm going to use the general term to create another linear equation in terms of A and D. Where there is Tn there, I'll put 28. Where there is A, I'll put A. Where there is N, I'll put 3. Okay, where there is D, I'll put D. Then I'll simplify, and I'll get 28 equals A plus 2D. So that's my second equation. Alright? Once you have those two linear equations, it becomes a grade 10 question. Because you were taught how to solve a pair of simultaneous linear equations in grade 10. So it becomes a grade 10 question. The solving for A and D becomes a grade 10 question. So what I'm going to do next is, it's your choice. I'm going to make A the subject in equation 1. So I'll take the 14D to the left. Okay? So I'm going to move on to the next page. Can I get on? So on the next page, I'll say, in equation 1, if I want to make A the subject, I take the 14D to the left. So I'll be left with A only on the right. And then I can write A is equal to 100 minus 14D. Okay? Okay, to avoid unnecessary confusion, I'm going to write this as 100 is equal to A plus 14D. Then I'll take the 14D to the left. You get 100 minus 14D equal to A, which means A is going to be equal to 100 minus 14D. Okay? Then I need to substitute now this new equation that I've made A the subject into the second equation. Substituting into equation 2. If I substitute into equation 2, this is my equation 2. So 28 is going to be equal to A plus 2D, but I now know the value of A in terms of D, so it will be 28. So that will be 28 equal to 100 minus 14D plus 2D. Are you following? If you want, you can also use the elimination method to solve those two simultaneous equations, but I prefer substitution. So this becomes 28 is equal to 100 minus 12D. Then I'm going to take the minus 12D to the left. If I do that, I'll get 12D equal to 100 minus 28, and I'll get 72 on the right, and I'll have 12D on the left. So if I solve that, I'll get D equal to 6. Okay?
So negative 6.
That means you made a mistake somewhere. Just check your work, you made a mistake somewhere. Okay? Are you following? Huh? Then, to find A, our A, we can use this equation, this one here. So A is going to be equal to 100 minus 14 times 6. So that will give me 100 minus, now that will give me 14 times 6, give me 84. Am I right? And then you will get 16. So the first term is going to be 16. Now, what was the question asking? Just give me a second, I want to go back. The question was saying, determine the 100 term. The term with the position 100. So we need to find T100. Now, once we have the value of D and we have got the value of A, we need to go back to our general term and substitute the value of A and the value of D. Okay? Then we substitute N equal to 100 to determine the value of that term. Okay? Are you following? Now, when you're doing a question like this, you probably need a full page because you have to do quite a lot of working out. So I'm going to move on to the next page. The next page, I'm going to write my general term first. It's A plus N minus 1 times D. Okay? For now, I need to determine what is the general term, then use the general term to find the value of a term with the position 100. So my A is 16 plus my D is equal to what? 6. So this gives me 16 plus, okay, that will be plus 6n minus 6. And then you get 6n plus 10. So this is the general term for that sequence. That's the general term. You can use this general term to determine the position of a term or to determine the value of a term. Okay? I'm not done yet. We want T100. T100 is going to be 6 times 100 plus 10. That will give me 600 as 10, and then you get 610. Okay? So that's the 100th term. Okay. Any question? So if you did the question, you can just do some correction. Now, it's better for you if I give you homework to do it. Even if your answer is wrong, it's fine. Okay, when I go back to class, you can see where you made your mistakes and then you correct yourself. If you didn't do it, you won't benefit anything. Let's say for this question, if it was in an examination, there was a mark allocated for the general term, and you don't have it in your solution. Everything is fine, but somehow you didn't show the general term. If the question is maybe 5 months or 6 months, you may lose it by 1 month for not having that general term. So I would encourage you to write it down. Find it and write it down. Okay? That's in case the examiner allocates the mark. Because a question like this is minimum 5 marks. In actual fact, I sent you a question, you saw on the group. I took a picture and I sent it on the group. I sent a question on the group. Today. Yes?
Can you submit with the end?
Where?
For the second job.
Yeah.
Can you submit 100 days?
Yeah, you can. But you see, I want to find the general term. You can substitute it. But the question is, what if there's a mark allocated for the general term in the question? Okay? And remember, it's not about the answer keys. It's not about this answer. It's about how you get to it. Yeah, that's what I'm saying. You will never know. All right. Any other question about this? Are you following?
Yes.
Okay. Then let's move on to the next one. The next question. Now, the next question, it says the sum of the first 10 terms of an arithmetic series. That's Sn now. It's now an arithmetic series. Okay? That's Sn. Arithmetic series. So the sum of the first 10 terms means if you add T1, T2, T3 up to T10, you get 145. And the sum of its fourth and ninth term is 5 times the third term. Now this is more like a problem solving question. Right? And this is very common under sequences and series. So first, I'm going to write an equation for the first part of the question. So it will be S. Okay, remember your formula for calculating the sum of terms in an arithmetic series is Sn equal to n over 2 times 2a plus n minus 1 times d. That's your formula, remember. For calculating the sum of terms in an arithmetic series. That's the formula. So, for the first part, which says the sum of the first 10 terms, it means I'll say S10 is equal to 145. Okay? Where there is Sn here, I'm going to put 145. Where there is n, I'm going to put 10 because we have got 10 terms. Okay? This 10 here. So that will be 10 over 2 times. We don't know the first term. Where there is n, I'll put 10. We don't know the common difference. Okay? So the question says determine the first term and the constant difference. So we need to determine the value of A and the value of D. Okay? Then I need to simplify this to a linear equation. To simplify it, it's not complicated. Okay, I'm going to do it this way. Divide 10 by 2, I'll get 5. Okay? And then I'll have 2a plus 9d. Okay, then I'll write here 145 equal to 10a plus 45d. So this will be my first equation. Okay? That's my first equation. It's in terms of A and in terms of D. Okay? Then, since I have two unknowns, I need to create a second equation. So the second equation is going to come from the second part of the question, which says the sum of its fourth and ninth term is 5 times the third term. Right? Now your English here is extremely important. Right? So let me move on to the next page. Now we have the fourth term. Okay, if you add the fourth term and the ninth term, the answer that you get will be 5 times the third term, which is T3. Okay, so this is how you write it. So we are saying T4 plus T9. It's T4 plus T9 is going to be equal to, now if I add T4 and T9, I'm going to get an answer which is equal to 5 times the third term. So that would be 3 times T3. Okay, wait. Is it? Okay, so it's 5 times, so that would be a 5, sorry. That's a 5. So that will be 5 times what? T3. Alright? Then, the T4, the T9, and the T3, we need to write them in terms of A and D. Okay? We need to write them in terms of what? And. Now, to make things easier, okay? Remember, T4, if I use this general term, right? By now I expect you to know it. It's A plus N minus 1 times D. So if I have T4, if I put 4 here, 4 there, it means my T4 is going to be A plus 3D. Do you agree with me? Okay? So, this T4 is going to be A plus 3D plus this T9 is going to be A plus 8D. Okay? It's going to be equal to A plus 8D. The right hand side, T3 is going to be equal to A plus 2D. You agree with me on that? But there's a 5 here, so that will be 5 times A plus 2D. Then, to simplify this, we get 2A plus 11D is equal to 5A plus 10D. Okay? Then I'm going to, to make things easier for myself, I'm going to take the term in A to the what? To the right, then the term in D to the left. If I do that, I'll get 11 minus 10D, I'll get D. Okay? If I take the 2A to the right, I'll get 3A, because 5A minus 2A gives me what? 3A. Now, this equation is going to be my second equation. Are you following? Then, since it's a very simple linear equation, right, I need to substitute where there is D in the first equation, I'll put what? 3D. Okay, because D is equal to 3A. So my next equation will be 145 is equal to 10A plus 45 times 3A. Okay, remember here, G is equal to 3A. So here I can say, therefore, 145 is equal to, I'm writing equation 1, 10A, okay, 10A plus this 45 here times D, but D is now equal to what? To 3A. Are you following?
So, how do you
I converted this equation here from the T form to A and D using the general term. This general term. Like T4 means where there is N, you put 4. 4 minus 1 gives you what? 3 times D, you get A plus 3D. If N is equal to 9, 9 minus 1, 8 times D, you get 8D, so it becomes A plus 8D. The right hand side, T3, okay, put 3 there, you get A plus 2D, but the T3 is not going to be multiplied by 5. So you end up having 5 times A plus 2D, then you remove bracket, you carry on the sugar with 5. Okay? Then, so here, I just want to remind you that it's 45 times D, but D is equal to 3A, so I write 45 first here. and then open bracket times what? 3a, like that. Right? So this becomes 145 equal to 10a plus 135a. Okay? And then you get 145 equal to 145a, which means your a is going to be a 1. If a is a 1, it therefore means that d is going to be 3 times 1, which gives you d equal to 3. So those are your two answers. Remember, d is equal to 3 times a. Okay? The following. Right. So if you have challenges when you're doing it on your own, after what I've done here, it should become clearer to do that. Right? But then the next thing is you need to sit down and attempt your own questions and do what I just did. Okay? Right? Any questions before I move on to the last one? Okay, if you don't have a question, then let's move on to the next one. Alright, the next one is on a geometric sequence. Okay, next one is on a geometric sequence. Now, with regard to all questions on the geometric sequence and the geometric series, you have to know your exponents. Your exponents are very important. If you forgot your exponents, go back to grade 11 and refresh yourself. Okay? I just want to emphasize to all of you that if you are in metric, it doesn't mean that you can't go back to a grade 11 topic and refresh yourself. No, it doesn't mean that. If you forgot, then go back and refresh yourself. Okay? Let me carry on to the next question. If you are behind, you can catch up with it. Right, now this question, it says if T3 is equal to 15 over 16, T6 is equal to 5 over 18, and the last term is 40 over 729, find the number of terms in the sequence if the sequence is geometric. Now, if you are talking about a geometric sequence, it means you need to know that T1 is equal to A, there is a common ratio R, which is equal to T2 over T1 or T3 over T2, T4 over T3, and so on. You also need to know its general term. Now, the general term of a geometric sequence is Tn equal to A times R to the power of n minus 1. The common ratio is equal to T2 over T1, which you can write as Tn over Tn minus 1. Okay? You have to know that. Also, you need to know that your T1 is equal to A. Right? Now, these are key concepts. Right? These are key concepts that you need to be aware of before you start answering this question. Okay? So, let's create our equations. First, we are given that T3 is equal to 15 over 16. So, what this means is T3 is going to be equal to, if I use, okay, it's given here, T3 is 15 over 16. If I use the general term, it means where there is n, I'll put 3. Where there is n, I'll put 3. So your T3 is going to be 15 over 16 is equal to AR squared. Okay? I can write the third term in terms of A and R. Okay? Then T6 is equal to 5 over 18. Okay? I can use that general term to write T6 in terms of A and R. So this will be 5 over 18 is equal to, if I put 6 here, it becomes A times R to the power of 5. So I'll end up having A times R to the power of 5. Okay? Now, for now, I can use those two equations, that is, this equation and that equation, to determine A and R. Okay? So I'm going to show you a mathematical technique that you are not used to, but which is very common when you are dealing with the geometric sequence. Okay? For now, I'm not going to use the fact that the last term is got 14 over 729. I'm going to use it later to determine n. Okay? So I need to determine the value of a and the value of r. After that, I'll use the fact that the last term is 40 over 72 now. Are you following that? Now, when you have got two equations like this, in mathematics, you have got two equations like this, whereby you have got monomials on both sides, right, like that. You can divide the left-hand side and the right-hand side. Okay? You don't need to make either A the subject or R the subject, and then substitute into the second equation. You can divide the left-hand sides and the right-hand sides on their own. Okay? You only do that if you have got monomials. You understand? If you have got binomials, then use the method that I've been using so far in terms of substitution. So, on the next page now, I'm going to say 15 over 16 divided by 5 over 18 is equal to AR squared divided by AR to the power of 5. Now, you are going to find that A is going to be eliminated because of that division. Okay? So I'm going to divide equation 1 by equation 2. Okay? So let's move on to the next page. So it will be 15. Let me use it, right? So it will be 15 over 16 all over 5 over 18. Now, your knowledge of fractions is extremely important, and you are taught fractions in the lower grades. So this is going to become equal to AR squared over AR to the power of 5. So whatever I did on the left, I also did it on the right hand side. Okay? And please remember that your main division line is this one here. And we can replace that division line by a division sign to make things easier. Yeah?
I was wondering if it's cool to just take in division sign.
Yeah, that's what I'm going to do. Okay, so I can write the left-hand side as 15 over 16 divided by 5 over 18. If I simplify the right-hand side, you are going to find that this A and that A will cancel out. Okay? Then you are going to have R squared divided by R to the power of 5. If you use your laws of exponents, that right-hand side becomes 1 over R cubed. Okay? Because we have got 2 R's on top and 5 of them there. So out of these 5, 2 of them will cancel with those 2. And you'll be left with what? 3. Now on the left here, you'll find that we can introduce multiplication and then invert those 2. So we end up having 15 over 16 times 18 over 5. This is going to be equal to 1 over R cubed. Allow me to carry on that side. Then, if I want to simplify this, right, you can use highest common factors. 5 into 5, 1 into 15, that's 3. Right? 2 into 18, that's 9. 2 into 16, that's 8. So I'll end up having 45 over 8. Okay? So that will give me 45 over 8 is equal to 1 over R. Okay, wait. I just want to remember I made a mistake. Oh yeah, 23 times 9 is 27. Thank you for that. So I was looking at this 3 as a 5 for some reason. Then I multiplied by 9. It's a 3. So this gives me 27 over 8 equal to 1 over R cubed. Alright? Now, when you get there, okay, I hope you are aware that you can swap the denominators in the numerators. You know that, or you can cross multiply. If you think you can get confused, then what? Cross multiply. But you can also swap these 2 and swap those 2. Do you know that? Mm-hmm. Okay? If you don't want to do that, then cross multiply. If you cross multiply, you get 27 R cubed equal to 8 then you divide both sides by 27. So your r cubed is going to be 8 over 27. Then you find the cube root of both sides. So that's 8 over 27. So your r is going to be equal to 2 over 3. Okay?
So what do you get for 8 over 27?
I cross multiply. This r cubed multiplies the 27, the 8 multiplies the 1.
Oh.
And then you divide both sides by 27. Which is the same as swapping these two and swapping those two. Okay, so I now know that my common ratio is what? 2 over 3. Now I need to determine the value of the first term. So to determine the value of the first term, I need to go back to one of those two equations. Okay. Right, a question like this can have 6 marks. Okay, if it comes in an examination, right, maybe 6 marks. Right? So I'm going to use that common ratio. Let me choose the first equation to determine the first term. So 15 over 16. Okay. So it will be 15 over 16 is equal to a times r squared. But I know that my r is 2 over 3. So that will be 15 over 16 is equal to a times 2 over 3 squared. Now, your knowledge of exponents is very important. If you have got challenges with exponents, then you are going to find the geometric sequence. Geometric series is very challenging. So this will be 15 over 16 is equal to 4a over 9. Okay? Then, I want you to be aware that the way that I wrote it here, because 2 over 3 squared gives me 4 over 9. I multiplied that a by the numerator, which is 4a, to make things easier when I'm simplifying. So that means I can cross multiply there. If I cross multiply 15 times 9, should give me 135, I think. Right? Yeah, should give me 135. Okay, then 16 times 4a. Okay, can you check that for me? 15 times 9.
64.
Huh?
64
I said 15 times 9.
Oh.
135. Then 16 times 4a, you get 64a. Then you divide both sides by 64. Okay, so your a is going to be 135 over 64. Okay, that's the value of a. Okay? Alright? Then, once I've got that now, I now need to find the last term. Now, if you look at the question, it says the last term is 14 over 729. Who can tell me the equation for the last term? What would be the equation? Tn
is equal to a plus n.
This is a geometric series.
Oh, it's Sn.
The last term in terms of a, r, and n will be equal to what? Yes, it will be Tn equal to a times r to the power of n minus 1. Remember, I told that the last term for a geometric sequence is a times r to the power of n minus 1. Okay? So that's Tn is set to 40 over what? Over 729. Right? So right here, Tn equals a times r to the power of n minus 1. Then you put 40 over 729. What is a? Is that 135 over 64, okay, times the common ratio, that's 2 over 3, raised to the power of n minus 1. Okay? Now here, your knowledge of exponents is extremely important. Now my suggestion is multiply the left-hand side by 64. Whatever answer you get, you divide by 135. Because, you see, if you want to simplify this, you need to take into account that first. You have to eliminate that the value of A on the right first. So divide both sides by 135 over 64. Can you tell me the answer? Divide this 40 over 729 by the value of A. What is
512 over 19,680.
512 over
19,680.
6 and what?
680.
683 like that.
Yeah.
This will equal to 2 over 3. Okay, can you verify the answer?
No, sir, it's correct. It's 512 over 6183.
Divide.
You know why you can't divide and
That's right there. No, so I used the divide sign.
Okay.
What did you say about
Are you getting the same answer? Huh?
Oh.
Are you getting the same answer? Alright, when you get here, right? When you get here, can you convert, can I have your attention? Can you convert 19,683 to a base of 3? Well, 512 can be converted to a base of
9?
Huh?
3 to the power of 9.
3 to the power of 9. So this 512 is going to also be equal to 2 to the power of what? Of 9. Are you following? Listen, remember, if you want to take on here, you need to make this 512 over 19,683 you need to convert it to a base of 2 over 3. Remember, to solve an exponential equation, it must have the same base. Don't forget that. Otherwise, you get to this point here and you get stuck. So this will be 2 over 3 raised to the power of 9 is equal to 2 over 3 to the power of n minus 1. I need someone to ask questions here before I get off. Huh? Any question?
So what is this? 2? No, we get it. We think the.
This? Okay. Do you see?
So what's equal to 19,000 then?
Huh?
How do you convert that?
It's no, you get 2 over 9. The factor and 12.
Yes.
What's equal to 19,000? Why the 3?
Yeah, it's 3 because this 19,683 it can be written using a base of 3.
I'm still confused. How do you get the 2 over 3?
Yes. Okay. Alright. It's a good question. Alright. Can I have your attention? When you come in the afternoon, I'll explain that part. Yeah, after the afternoon. I'll explain that.
Oh,